Okay, so thank you for having me here, and my name is Hilkka Kallio. I come from the Geological Survey of Finland, and I'm a project manager in a project called GeoModels in Engineering Geology and Land Use, and also a member of Urban Geology Expert Group. And first, when I started to think like what kind of geological 3D models I will present today, so I really had to do some excluding work. There's a lot of different kind of models we are doing for different purposes. And I decided to concentrate for the examples we have done as an client assignments for the public sector, for building developers like municipalities. And I will leave out some of the models that are more like academic exercises still. So for that category goes to the structural geology and rock mechanics. And also, so there we don't have yet so much commercial projects going on. And then the low carbon energy solutions I will also exclude, because there's a lot of commercial projects going on, but it's an entity of its own and deserves an own presentation. So what I'm going through in my presentation are the ground conduction models of superficial deposits. What we do, then the characterization of fine-graded sediments, especially the sulfide clays and sediments of the coastal regions that used to be, I would say, quite overlooked issue earlier, but during recent years, so they have been taken into consideration much better in land use processes and land use planning. And the traditional modeling what we do are the groundwater area structural surveys and groundwater flow models. And first of all, I would like to go through some factors behind the geological 3D modeling approaches in our geological survey. So one important factor is the complexity of quaternary environment we have. So the layers in Finland, they are normally very thin. There are many rockhead outcrops everywhere, till and glaciofluvial deposits, and in between some fine-grained sediment basins. So to model this kind of environment, you need a lot of source data. And what we are lacking in our geological survey are the stratigraphical cross-sections and borehole logs, what many other European geological surveys have a lot in their registers and databases. But the data we have a lot is the geotechnical site investigations from the construction industry. And the areas, the not so urban areas, arable land areas, where there naturally is not so many geotechnical site investigations. So we try to cover as well as possible with geophysical measurements. And about the geotechnical site investigation data, so we have a large number of in situ tests, similar like CPT, cone penetration test, for example. But then we have just a few samples from the sites. So what we are doing at the moment, we are putting a lot of effort for the interpretation of the geotechnical in situ tests. It's a lot of work to do because there is so many of these drillings. And I would say at the long run, it's very unsustainable situation for us. So we are looking to the future and trying to find some solutions how to automate the interpretation work in the future. And one solution would be the numeric modeling with drilling resistance data, and of course machine learning of geotechnical profiles. And what I'm very proud in our country and about the data we are using is the data standard and the data storage regimes we have. So GTK maintains at the moment the largest site investigation register in Finland. So many municipalities, they are just happy to allow to us manage their data sets. They see it as a bargain. Of course, there are some large cities who want to maintain their own data sets and take care of the sharing, and it's okay. It's okay. The most important part is that it's stored somewhere and it's shared proper ways. No matter if it's our survey or the city administration. And we have also very nice harmonized data formats for site investigations. I would like to compare it to the British AGS format. So it looks different when you open the data file, but anyway, there is a lot of similarities. And I made some, I was comparing the British format and the Finnish format and found a lot of similarities and some differences. But here on the right side, I have an example of the most typical drilling method and drilling data from our register. So this is the Swedish weight sounding test. So you have here, the first column is the depth of the drilling. Then you have some parameters, weights and number of rotations, and then some kind of an idea from the driller, like what is the soil type there. And so almost all the site investigation data fits to this format. We have there many different kind of drillings. There is in the middle is an example of undisturbed sample data, and then on right, water table level measurements from a groundwater well. And here is a screenshot from our site investigation register. This is an area from city of Tampere. So you see the drillings quite irregularly placed in the areas. Or some areas there's a lot of them. So you see the scale here is 300 meter. So in a square, 300 meter times 300 meter, you can have like hundreds of drillings in certain parts, and somewhere you don't have so much. This is now a modeling example from city of Tampere area. So the city of Tampere, they were interested to know what is the infiltration rate of the lake water into the esker. So they are planning a landfill area, some man-made islands here for housing, new housing area. And they were worried like it will affect to the aquifer we have on the esker area. And they wanted to know what is the infiltration rate of the water from the lake to the esker. And the estimated first estimated idea was like the infiltration will be 1,000 cubic meters per day. So they asked the Geological Survey to make their own estimation, and they also asked a geotechnical engineering agency to make their own estimation. And first I will show like the geotechnical engineers were doing. So it was very simple 2D finite element analysis. They made one cross section here at the shoreline. The cross section is shown here. They analyzed the soil types and got the result like 60 cubic meters per day, the infiltration rate. So this is much less than this first estimation of 1,000. So our Geological Survey made own modeling approach. We were modeling the whole aquifer system, first making the geological model. Here you see some cross sections of the area of the esker made with groundhog software. And then we made, let's say, traditional flow model of the aquifer. And the result of GTK's analysis were that the infiltration rate would be 155 cubic meter per day. So it was funny to compare two methods. The very fast one made by the engineers and our method. It's hard to say which one is now more accurate, but at least the results have the results are on the same scale to compare the earlier estimation. So the city knows now that the infiltration rate is not that large as they were thinking from the beginning. Here is another model we made for the city of Vantaa. It's about the quaternary layers. So you see the modeling area, the large area here, and this area of a smaller version of the model. And so the model of the large area is not yet ready. I cannot publish it, but I can show this smaller part. So this is a very typical let's say Finnish southern Finland geological setting with some short deposits on the top, then clay, silt, fluvial deposits still, and finally bedrock. And we made two models, one with a geological modeling software and one with CAD-based modeling software for civil engineering, and compared the models. And here is closer look of the model one cross section there. So you see here are the data here is like all of the data is the geotechnical investigations here, and what we are doing the interpretation of the drilling resistance data to the geological layers. And we are also doing some ground condition modeling in different cities. This is an example from the city of Espoo, what we did. So the idea is to automate the process of interpretation by filtering only the essential information out of the digital data sets. And the results are quite promising, I would say. So the source data we were using are the site investigations, geological soil map, and digital elevation model. And with some GIS work, we could create this kind of ground condition map based on this classification, I would say rather fast. So there is a lot to develop on that side, but the first results are promising. And then this is my last example. I told you the sulfide sediments important issue at the moment, and in GTK we do a lot of research with them on many different scales, on national scale, on regional scale, and even on local scale. This is an example of assessment of the areas of potential sulfide clays. It was an assignment from the city of Espoo. So they want to direct their large-scale soil sampling measures to the areas where they see that the risk for sulfide clay occurrence is the highest. So it's about saving the money, that you don't have to make a big soil sampling program to the areas where there is maybe no risk at all. So, but anyway, so thank you. I hope you got a general overview now what kind of modeling work we do in our survey. Thanks.